All right, my friends, here we go. Another day, some more great algebra. All right, so the good news is that we're really going to be talking about the same topic that we just covered in our prior lesson, solving mixed systems of equations. But what we are going to do today and into tomorrow is talk about how to solve them analytically or with equations, because it's not always convenient to graph everything and find where they intersect. We don't always get nice, pretty answers. The graphs may not be really good to graph in a 10 by 10 grid, which we're used to. So we really need an algebraic process to solve for those points of intersection. So to get you thinking about that, let's go back to this problem. All right, this was the opener that we did graphically in our prior lesson. So what I'd like you to do now is solve this algebraically. All right, so go ahead and pause the video, do a little bit of algebra here. We'll turn it on. We'll see how you did. All right, so I'm going to throw my work here, and we'll see how it compares to your work. Now, you may not have all of this work right now, but that's okay. We'll talk a little bit about the extra stuff. So hopefully you started by setting the two functions equal to each other here. All right. Now, what we know is both of these are the absolute value of x minus 3, so we can treat those like terms. So I can add 2 times x minus 3 to both sides. That gives me 4 times the absolute value of x minus 3 minus 2 equals to 2. We can add 2 to both sides. We can divide by 4. And then what we know is we have two possible numbers that have an absolute value of 1, positive 1 and negative 1. And then that allows us to solve for our two solutions there, which is 4 and 2. Now, what I did here was really that verification process that we talked about in our prior lesson to show and to check my work. So when I plugged in 4 into f of x, I got 0. When I plugged 4 into g of x, I got 0 again. So not only do I know that my work is correct, I verify that it is, all right, a point of intersection. And then very similar manner here, except for I wrote g of 2 here instead of f of 2, so let me just correct that. All right. When I plug in 2, I get f of 2 is 0. When I plug 2 into g, once again, I get 0. So I know that that's a point of intersection. Now, all of this is just extra work. That's just a way for you to double check your work. So you should be doing this on a self-assessment, on a regular assessment. It's just a great thing to be able to do. All right, so now let's look at, all right, this question. And so what I'd like you to do now is try to solve this equation, all right, or this system of equations, and maybe think about how it's different than the prior one. So go ahead and pause the video, try that, and then we'll turn it back on and see how you did. All right, here we go. All right, now, so once again, we'd start off in the same kind of manner to where we would take and set the two functions equal to each other, just like we did above. Now, notice though, there are no like terms here. So how do we solve this? This is really what I was hoping you would get to, that this is more difficult than the opener, all right, because we don't have those like terms where we can move things around, all right? So the way we solve this is that we need another tool. And that tool that we need is something called a piecewise function, all right? Now, what a piecewise function is basically we're going to take multiple functions and we're going to put it together to create one graph, one function. All right, so that's what this video is going to do right now, is give you an introduction to what a piecewise function is. All right, so now if we look at the next page, and we're going to go through these together, all right, that way you have an understanding of what a piecewise function is. So first, it's really a rule, all right, or multiple rules. So we're going to look at the function 3x minus 2. Now, one of the ways that a piecewise function is different is it typically gives us an interval to work with. So notice if we just normally graph 3x minus 2, it would go on forever to the right and to the left. But that's not what's going to happen here. So what this rule is telling us is we're going to graph this line, but we're only going to graph the line from -2 to 1. All right? So now if I plug -2 into my function here, I get 3 times -2, which is -6. -6 minus 2 is -8. So I'm going to start at -2, -8. Now here's the thing. It's a less than symbol. So just like when we do inequalities, right, we know that typically when I have less than or greater than, we have an open circle. All right, when we have less than or equal to or greater than or equal to, we have a solid circle. That still applies when we're graphing in a piecewise function in the coordinate grid. So notice, since this is a greater than, I'm going to graph -2, -8, all right, but I'm going to put an open circle on it, just like that. And notice then, if I plug in -1, -1 would be the next number, right? So -1, so -3 times -1, all right, is -3, minus 2 would be -5, right? And we'd get -1, -5 is here. Now the other thing is, we know the slope is 3, right? So I could just do my slope from here. So I'd go up 1, 2, 3, and to the right one, and notice I get that same point, -1, -5. I'm just going to go ahead and do that again. So I'm going to go up 1, 2, 3, to the right one. I get my y-intercept of -2, which we can see in our equation here. Now notice I have to stop at 1, and I'm at 0 right now. So if I go up 3, 1, 2, 3, to the right one, I get to 1, 1. Now notice this is less than or equal to. So I'd have a solid dot, 1, 1, just like we would know. And so notice now, this is the graph I get. And that's it. So one of the differences with a piecewise function is that it puts intervals on our function. All right? Normally we'd continue going up here, and we'd continue going down here. Okay, so that's one of the major differences with a piecewise function. Okay, so now let's build off of that. So now if we look at number 2 here, notice that 3x minus 2 is the same rule we have here, and -2 to 1 is the same interval we have here. So just for time's sake, I'm just going to transfer what we did here to this graph, because we already know how that works. So -2, -8 has an open circle. We go up 1, 2, 3 to the right one, up 1, 2, 3 to the right one, up 1, 2, 3 to the right one. All right. So that's our first part of our graph. That's the first piece to our graph, and that's why it's called a piecewise. Now notice the next piece, or the next function, or the next rule is another line. It's 2x minus 8. But once again, we're only going to, and this should be a positive 5 here. So let's do that real quick. It should be a positive 5. Big typo there, so let's go ahead and correct that one. All right, but we're only going to do this rule from 1 to 5. All right, so only from 1 to 5. So now if I plug 1 in here, I get 2. 2 minus 8 is -6. So I'm going to start at 1, -6, which is right here. Now once again, we have that open circle because of our inequality symbol. So we have 1, -6, that open circle. All right. Now, once again, we can just use our slope, all right, till I get to positive 5. So I'm going to go up 1, 2 to the right one, up 2 to the right one, up 2 to the right one, up 2 to the right one. Now, once again, this has a bar, so we know it's going to be a solid circle right there. And then there is our graph. So it's called a piecewise because we're going to piece together different graphs to form an overall graph. Now, if we go back to our second unit when we talked about what is a function and how do I determine if something's a function, we talked about the vertical line test. All right, so notice this passes the vertical line test because the only possible issue could be at x equals 1 here. And notice we only have 1 point because it's a solid circle here, but an open circle here. And as long as that happens, it will be a function. All right, and we should already know, right, we're in function notation, so that would have to work out. So if for some reason the graph you create does not pass the vertical line test, then something is wrong. Go back and look at your interval, look at your function. All right, something went amiss. Okay, so now let's look at our last example together for this lesson. All right, so notice we have 2 rules, right? 2 pieces. We have a line, but we can only do this line for less than or equal to -2. We have a second line, but we can only graph this line for greater than -2. All right, so I'm going to go ahead and plug -2 into this function to see what y value I get. And then notice we know whatever point I get is going to be solid because of the bar. So if I plug -2 into here, right, that's 0. 0 times that is 0, so I get left with -2, -4 as my starting point. So -2, -4, and we know it's going to be a solid dot. Now I have to do everything less than or equal to -2, which is really to the left of this point on our graph. I'm just going to use slope. So normally it has a slope of -3/2, so I'd go down 3 to the right 2, but I can't go in this direction because I have to go to the left. So I'm just going to reverse my slope. I'm going to go up 1, 2, 3, and back 2, up 1, 2, 3, and back 2. And then notice it can continue going on because I'm doing everything less than or equal to -2. So basically we're just getting part of this line that extends up and to the left forever. Okay, so now let's look at our next rule. Okay, now I know I'm going to start at -2 again, but it's going to be an open circle around that point. So if I plug -2 into this equation, that's 0. 0 times 3/2 is 0. So once again, I'm starting at -2, -4. And an open circle around a closed circle is still just a closed circle. All right? And now I have to do everything greater than -2, which is I need everything to the right of this point. Okay, so I'm going to just do my slope. I'm going to go up 1, 2, 3 to the right 2, up 1, 2, 3 to the right 2, and notice what I get here. Does that look familiar, my friends? All right, hopefully it does. And now you might see why we need piecewise functions, because we can write an absolute value function as two linear equations, which then will allow us to create linear equations to solve for those points of intersection. All right, that was the big idea for today. We'll pick up with some more piecewise function work next time we see you. Have a good night, do your video check-in, and we'll see you next time.